So yes, I think this is definitely the interpretive dance segment of the workshop. There are many things you'll want to think about this talk. One of them certainly is my voice. I wasn't sure I would make it, having had a nasty cold. Can you hear me down the back? No? That's fine. Yes, this is taught by me and my student Timothy Jones, who did the Haskell, which I hope we won't have time to get to for reasons that are obvious. Littlebits.cc is, one of those TED, quick starter, trendy companies from New York or California. Yeah? Okay, they want to sell really expensive electronic components. Schools for use in teaching electronics, basically, and they've got enter-to-win devices on the front page. You can go to it. They have a website. Websites. Someone told me off the e-book talk that it was more stand-up comedy than actual content. I didn't mind. One thing they say repeatedly is there's no programming here. They're really proud of it. They were, at least until they introduced the other books. Make big things happen with no programming, no wiring, and no soldering. So, they're really quite keen on this idea. Here was another one of their ads. It's easy to connect things to the cloud. All right? As with littleBits, no wiring, soldering, or programming required. Okay? What littleBits actually is. Okay? And I would hand them around, but the little bits, I have some here, they're actually all rather expensive. It's like $120 US for something like this kit, and you don't have very many bits in it. And in fact, the one I showed previously here, this is their new cloud bit. Okay? And the idea is it's all really, really simple. You can plug this into another little bit, and you get precisely 8 bits of output. To, for example, a number between 0 and 255 on a web page. And you get 8 bits of input that you can use, to control the brightness of a light. And they use it, something which you functional programmers will be all very, very clear on. They use abstraction to do it. Okay, the way they do it is, this thing here is a fully equipped Arduino multi-controller system on a chip. That's it. And this lets you take this thing out of the box, stick it onto your Wi-Fi, connect to the web server that this thing is running, give it the password for your Wi-Fi, reboot it, and then, from your own network, you can ask it for the 8-bit value. As I said, I brought a bunch of these things with me, so this in particular is the synthesizer kit, which is one part of my job. I do have another justification for being here, which I'll talk to people in the bar after the performance this evening. I did have basically fun getting these things in through Heathrow. Because what you've got, for example, on these bits of hardware is, there's a battery, a switch that makes a red light come on. And, let's see what else we've got here. There's a delay unit. I might not necessarily use that one yet. Oh, okay. Ooh, there's a pulse trigger, it says. So put that in there, and I'll wire up something else. And basically, I was aware, unfortunately, after I did say, "Would you like me to take the other electronics out of my bag?" They said no. And then they said, "Do your running shoes have computers in them?" Is it one of those? And I said, "No, actually. There's a bunch of electronic equipment. Got it out of the bag, showed them, explained I was coming in to give a workshop like a university professor." And I didn't mention what I had realized is that you did basically have everything you would need there to sort of, make, a trigger for any kind of bomb that you might have in the process of trying to get through Heathrow. So, anyway, that's basically the little bits. Why on earth are we talking about them here? Well, I'm going to skip ahead. Justification. Where's the other pictures? Here we go. We'll get back to Haskell if we have time. When people talk about this kind of stuff, right? This is actually Java, which is one of these live coding languages. Okay, saying, well, look, you can put code. If you're writing code, textual fetishism. If you're writing code, it's real, and you can be staunch, right? Maybe if you're slightly less staunch, perhaps you're from a music department. Anyone here? No. Okay. Well, for those of you not from the music department, this is the way most computer musicians write code. Okay, this is a max patcher. Right? It's, well, you could call it data flow functional language, except it was invented in the 1980s, so it was called a data flow object-oriented language.
Even worse. It's even worse.
Even worse. It's kind of both. More Swedish technology. Again, in the Swedes have cool technology. I was in Spotify's headquarters. I don't know where you had your conference dinner. ECOM had its conference dinner at Spotify headquarters with a live band. So there might only be half as many people were here, but that's cool. Right? This is your modular. You can program this kind of synthesizer by doing that. And there's enough here that you can think about this as well. This is the kind of things that a lot of the techniques we use in analyzing programming languages you can do. You can work out where things go. There are rules about which modules can be netted into which. There's actually all our favorite kind of, well, like I said, this has kind of got syntax coloring, hasn't it? This is these yellows are full audio. No, the red is full audio rate. Yellow is low audio rate. Blue is something confused about which color it ought to be. It's a deal. And in fact, many years ago, I did a corpus analysis treating all the kind of patches that were in for the synthesizer and showed you could actually find interesting things about the way people tend to put these programs together by analyzing module choice and all this kind of stuff. So this is all somewhat kind of sensible. Where we jump the shark is if something like that can be considered a programming language, why not, where my laptop is presumably dying, oh, it was doing something, it's not what I wanted. Why not something like this? So here's a little bit of Synth Kit, and yes, I do actually do this live with one of my bands. I warn you, the last time it was a digital metal concert. And we're going to see why. So, you can say, there we go. Here we go, and so we've got some power, we can plug in an oscillator, we can plug in a speaker. There it goes. That is the real sound of analog. Can you hear it down the back?
Yeah.
The answer is no, and then of course there's the big reveal where, with the large power system on, plug it in and
can you add reverb?
I did a demonstration, and they always put me after morning tea or after afternoon tea, and I don't know why. The editing environment has some issues. But there are also a number of other important features, Everything sounds better when it's loud and it's got lots of reverb. So that's basically it. There are a few other things we've got here. Can I again point to the syntax coloring on the devices? So, yes, there are also syntactic issues because they won't actually go together the wrong way. Look at that. That's patented, that is. It's a type system. It is a physically embodied parser. I mean, why not? Can we get this one working? Sequencer. More analog beauty. Sorry. Excellent farting noises in 15 minutes. That's right, for the functionally active people, there's a rate knob. There we go. There we go. Okay. Let's see what I can use for money. There we go. Am I going to be able to escape the hassle is the question. This is Paul, when we were showing him, said that's really monadic hardware. Actually, I want to argue it was monadic hardware, but the kind of people who cut my paper down to 2 pages. So if you want to see the other 3 pages of it, you've got to go to the VisSoft conference in Vancouver early next month. One of the arguments was the whole point of this is the monadic hardware. There is the end of this thing. You can have a look at them afterwards. And I argue that the whole point of this thing is that not even music and any other bit of electronic equipment, the reason this all clips together is precisely because a very clearly designed, in this case, patented monad sticking at the end of it. And basically there's this little thing here, which takes power out of one end. Power in one end. That sticks you into the monad. I'm sure you can remember the name of these operators. And then basically every other thing gets coupled together. And if you're feeling really fancy, yes, you can go sideways. So you can, we're only out of time to do the full thing. You can see how this works. There are a few extra wires and things, so if necessary, you can, you can take power off in 2 directions. One in there. Oh, some power. Good. Anyway, where are we actually getting to it? It doesn't make any noise, you don't have an oscillator. Right. Content, I'm not going to be able to take Haskell, am I? Haskell isn't actually the content of this paper. But I figured it would get me a trip to glorious Rockwell. But is it Haskell? There was supposed to be 2 parts to that slide, wasn't there? Some of the dimensions. Yeah, so we did model this with Haskell. It's kind of pushing this argument out a little bit further. Although I've been reliably told that it's arrows. It should be arrows instead of monads. But I don't claim to understand Haskell, so you can send an email to the graduate student in Haskell. Basically, the notion here is, as I said, the fundamental difference is modules are those which effectively take some kind of input, and modules like this power module that take an outside source of power, so model that with the data structure. You can clip things together, which basically says, well, if you clip something onto something that's powered together, then guess what? The whole thing is powered. And if you clip together 2 things that aren't powered, they're not powered. And we can do this statically typed. And then basically you can model other circuits as usual sort of arrangements of monadic thingies, and put it all together, and this is actually a circuit virtual, but you can describe it. This shouldn't really be a surprise. You can do this in Haskell, because Utopia and a whole bunch of Haskell systems for doing music and synthesizers are out there and work on exactly these principles. If there was a point to this talk, I guess it would probably be that, there are more things in programming than are in your philosophy, Horatio. That it's not entirely stupid when we start talking about embodied programming languages to actually start talking about these kind of hardware. When we think about the techniques, and that's what we'll miss out on, techniques like the Alan Blackwell's cognitive dimensions technique for analyzing notations, these kind of hardware designs are perfectly susceptible to being analyzed by those sort of programming language techniques. So yeah, what was the line? Physically embodied, hardware, monadic, functional programming languages. littleBits, it's time for coffee. Thank you.
Of course, we've all got questions. Throw your hands up if you've got a question. No questions. 2 questions. Yes.
Forgive me if I'm being quick, James, but what was the connection between the Haskell and the hardware you're plugging together?
The Haskell is nominally a topological model of the hardware.
A simulation.
Yeah. You can't actually program the Haskell and build a hardware. Yeah.
What's your plan for going back through the process?
To take these things out of my bag for security and have a copy of the conference program with me.
without the recording about the bomb.
How does it go? I mean, is electricity a monad, for example, you know, or some really sub-level, you know, physical process down at that level? Would you want to speculate about that?
Well, I care to speculate.
Yeah.
Well, no, I'm neither a physicist nor a functional programmer. Friends of mine who are physicists tell me it's groups all the way down.
Right.
Go on.
Why is it helpful to take the word monad and make it mean nothing?
I don't believe I'm the first offender.
But you're maybe one who should know better.
I'm not arguing it means nothing. I think in terms of the... So I could be drawing a fairly long bow, but I don't think I'm drawing as long a bow as is drawn in social text, for example. Part of the reason that this works is because there is a standardized hardware interface that makes sure that all the various bits...
Sure, that's called an ADT. What about this is like a monad? Where's the return?
You see, I tell you I don't really understand monads.
Right, so why are you talking about them? Why are you using the word if you don't know what it means? You should know better than to do that.
Fine, I'll make that point.
No, you won't. You're going to go off and do it again anyway.
No, I probably won't go off and talk again about monads in this way. I'll talk about something else.
Why isn't the return just the sound output?
It isn't.
Because it's not both the left and right identity, Paul.
But I think like what is interesting is that there is there's kind of lots of algebraic things we know about circuits, and this has a very long history, and we can do things like fan outs and fan ins, and there's how you build these synthesizers and stuff, which is cool. And I guess the littleBits is like encoding some of the programming interface we have in our languages, like you were saying with the coloring and the things that do and don't go together. You know, if you're just wiring up synthesizers, kind of everything goes together and it breaks, but it's kind of cool, the littleBits, that there's things that stop you. It is like sort of a, as you say, simple type system that like stops you doing certain things, but it gives you a nice way to, you know, constrains you slightly compared to just wiring up classic synthesizers.
Oh, sure. I'm not particularly set on defining them now, but I'm certainly thinking this kind of stuff can be analysed by all the techniques that we use.
But just to be clear, right, I'm not saying that there's nothing of interest here. There might be quite a lot of interest here. I'm not even saying that what you've said, that it's wrong to say that there's a monad there. Maybe there is. But you don't know enough to talk about it, right? This talk is not even wrong.
Right. Most of this talk wasn't about monads.
So only all of it worked.
Any more questions that aren't about monads? Specifically? Well, thank you very much for the talk. It was very honest.